channel and continuously subscribe to my channel, hit that like button and share the information. Right, today grade 12 we are going to be looking at the subtropical anticyclones and associated with weather patterns, isn't it? Right, so in terms of location, these anticyclones are located along the subtropical high pressure belt, which is south. So because we are looking at South Africa, we're just going to look at the subtropical high pressure belt at 30 degrees south of the equator. So this is the map of South Africa, and here we are looking at so that's the location. We have three pressure belts that mainly affect South Africa. On the western side, we've got the South Atlantic high pressure system. This South Atlantic high pressure system, what does it bring? It brings southeastern, it brings cool southeasterly wind into South Africa. And on the eastern side, we have the South Indian high pressure cell, and this one, it brings warm, moist air, which is basically the northeasterly wind into South Africa. So these are the pressure belts that we're mainly looking at. Now in the interior we're mainly affected by what is called the Kalahari high pressure cell. It is this one that mainly tends to affect the interior parts of South Africa. So grade 12s, you need to know location. You also need to know these high pressure cells. Now, what are the characteristics of these pressure belts, of high pressure cells? What are the characteristics? Characteristics of high pressure cells. Like the name suggests, one, we should know they are associated with subsiding A. So, associated with subsiding or sinking A. That is the first characteristic of this high pressure system. And then if you look at the circulation of the A, it is anti-clockwise in a high pressure cell. So air circulation is anti-clockwise in the southern hemisphere. That is why we are calling them the subtropical anticyclones. And that's why I drew the diagram which shows anti-clockwise circulation of air there in the southern hemisphere. Right. I hope you have taken note of all these high pressure belts and also the notes there. And also we need to take note of why is the warm moist air on the eastern side, the South Indian, why is it warm moist? You should know that it is influenced by the Mozambican current. On the western side, why does it bring cool dry air through the southwest easterly? You should know that it is influenced by the Benguela current there, which brings cool conditions. Right, we are still on the characteristics also. Still on the characteristics, grade 12s. You also should know that during summer, the cells are weaker because of the warming earth. The warming air which rises, and in winter they are stronger. And then the reason why is they are stronger is because of cool air sinking. Now these are the main characteristics that you should know when we are looking at these subtropical anticyclones in South Africa. Now we have looked at what happens to the South Atlantic and also the South Indian. The South Indian, we said it brings warm moist air into the interior because this warm moist air is influenced by the Benguela current, by the Mozambican current. On the western side, it brings cool dry air which is influenced by the Benguela current. Now what happens to the one that affects the interior? What happens to the Kalahari high pressure, which mainly affects the interior? And when we are going to start to look at this, we're going to start looking at the winter season. Now what happens in winter? We all know that South Africa is influenced by the plateau, which we do have a plateau. So we said this is influenced by descending air. This is the Kalahari high pressure descending, and as it sinks on the surfaces, it warms up, so it creates what we call an inversion layer. This is the inversion layer. So as it sinks, it creates an inversion layer. So what happens as the Kalahari sinks? It creates an inversion layer, and this inversion layer is below the escarpment. It falls below the escarpment. This is the ocean here. So as it falls below the escarpment, it means warm air that is rising is blocked by the inversion layer. Warm air is blocked by the inversion layer. No condensation takes place, and this will lead to, what will it lead to if there is no condensation taking place? It will basically cause dry conditions. No rain within this particular region. So no moisture is able to rise. Only dry conditions are experienced because of this. So this is what is very important, and in examinations at times you might be asked to explain with the aid of the diagram. Now what happens to the Kalahari in summer? The Kalahari high pressure and this is in summer. And again we explain in relation to the plateau also. Now the Kalahari high pressure, you should know that its movement is basically vertical, isn't it? In winter it falls below the escarpment because it is sinking, but then in summer now it moves up. Why does it move up? Because there's a lot of heating on the earth's surface, so air is rising. So our Kalahari high pressure moves in the upper levels of the atmosphere. So as it moves in the upper levels of the atmosphere, also the inversion layer is above the escarpment. So as it goes above the escarpment, what happens to the warm air? Warm air is able to rise. is able to rise above the escarpment. And this will allow for condensation, which will lead to rain formation. This is our plateau. So air is able to arise above the plateau, and we can experience rain conditions during the summer. So you should also take note of this and be able to draw this. And then one is going to ask me, what is an invasion layer? Remember from your grade 10 geography, as the Kalahari is sinking, it warms up. So when we talk about the invasion layer, we're talking about warmer temperatures with increase in height. I hope you found this lesson beneficial, grade 12s. Keep on subscribing, and see you in my next video. Thanks, bye.